Tonight we're going to start with lesson 4 with our fractions. I can decompose fractions into sums of smaller unit fractions using tape diagrams. We see 2/3 and the tape diagram is set up for you, and we want to know what another fraction that we could get that would be equal to 2/3. Well, we could actually cut this in half and find a new fraction. And a new fraction would be, we have 1, 2, 3, 4, 5, 6. So we have 6 in the denominator now. And how many do we have colored in? We've got 1, 2, 3, 4 in the numerator. So we have 4, 6. So 2/3 and 4/6 is what we would call equivalent fractions. I'm actually saying the word when I say equivalent. You're hearing the word equal. Okay, so equivalent fractions means that the fractions are equal. So 2/3 is the same as saying 4/6. In the next one, they're showing you the fraction for a half. So this right here, this tape diagram is broken up into halves. Here's a half, and then here's a half. And they have the same one over here. Here's a half, and here's a half. So we're going to focus on the half, and we have to figure out 2 other equivalent fractions that would equal a half. Well, what we could do is actually just cut the half way in between. So now you have 2 in the numerator because now 2 is colored in. And how many in your denominator? Because you broke it up, it's 1, 2, 3, 4. So 2/4 in your denominator. So 2/4 and 1/2 are equivalent fractions. Moving on to the next one. They are showing you a half, and you want to find another equivalent fraction that would equal a half. Well, here we've cut it into a half and here. But now, since with this one we cut in half again, how about we cut it into 1, 2, 3, 4 fourths? So if we're cutting it into fourths, this one, 4 times 2, would give us 8. So this is 1/8, this is 1/8, this is 1/8, and this is 1/8. So we have 1/2 is equal to, how many are colored in? We have 4, and each one of those boxes represents eighths. So 1/2 and 1/2 and 4/8 and 2/4. Okay, so we have over here 2/4 and 4/8 are 2 equivalent fractions to a half. They're equal. Okay, in our next example, the tape diagrams are cut up into thirds. 1, 2, 3. Over here, 1, 2, and 3. But we want to find 2 other fractions that are equivalent to 1/3. So what we did here is we sliced each one of these 1/3 in half, and we've got now, because now since we have denominator, we have 1, 2, 3, 4, 5, 6. It's now cut up into 6. The unit fraction now for this is 1/6 and 1/6. So what is the equivalent fraction to 1/3? Would be 1/6 plus 1/6 would give us 1/3 equals 2/6. So 1/3 and 2/6 are equivalent fractions. But we can do the same thing for over here now. All right, so how many do we cut in? We cut 1, 2, 3 sections in each one of these thirds. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 in the denominator, because that's what we cut it up into. And we've got how many colored in? Well, we have 4 twelfths. So 4 twelfths is also an equivalent fraction to 1/3. So we've got 2/6 and 4 twelfths are both equivalent fractions to 1/3. All right, our next one is show that 2/3 is equivalent to 6/9 using a tape diagram and a number sentence. All right, so let's start making our tape diagram. In our tape diagram, I'm going to cut into thirds, and we've got 2/3 shaded in. And then it says, but now we need to use this tape diagram and model how it's equivalent to 6/9. So if we go like this, 1, 2, we cut it up into thirds. So now what do we have? We want to represent 2/3 and 6/9 to be represented, and we did. Because if you see over here, this is 2/3, 1, 2, 3, 1, 2, 3, and now we have 6/9. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and how many are colored in? 1, 2, 3, 4, 5, 6. So we would say 2/3, 2/3, and 6/9 are equivalent fractions. Okay, and our next one is a tape diagram that shows 3/4 has been colored in, and again only the 3 is shaded in, so the numerator represents the 3, and it's cut up into 4 parts. So now we want to decompose and show the shaded fractions and see if we can come up with another way of showing 3/4. So if we try to cut this up, I'm going to split this up, cut this right in half. Now we have 1, 2, 3, 4, 5, 6, 7, 8. Even though this is not shaded in, we still have to count it because it's broken up into 4 pieces. But now we broke it up into 1, 2, 3, 4, 5, 6, 7, 8. So our denominator is going to be 8. So I'm going to make my 8. And 3, so 3/4 equals 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 and plus 1/8. So what is really 3/4 equal to? If we add all of this up, 3/4 would equal 6/8. And that would be called an equivalent fraction. And if we check back at our tape diagram, we would see 1, 2, 3, 4, 5, 6 are shaded in. Let's say they asked us for 3/4 again, and they're asking us to make it a different way than when we broke it down into eighths. So another way that we can do this is last time we cut it in half. What happens if we split it up? Oops. we split it up into 2's. All right. So now what do we have? Well, we have 3/4 is equal to, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So one of these things is equal to 1/12. So our denominator is going to be 12, and we have shaded in 1, 2, 3, 4, 5, 6, 7, 8, 9. Did it again? 9 in the numerator. We shaded in 9. So 3/4 is equal to 9/12. And if we broke this down further, we would want to do 1/12 plus 1/12 plus 1/12. And 1/12. That's how we decompose it. So 3/4 is equal to 9/12. Okay, now we have something a little different. 2/5 equals 4/10. And you're going to need to draw a tape diagram to prove the following statement. So let's try this. Now we have fifths. So we need to create a tape diagram. And that's broken up into fifths. Okay, so this one has been broken up into fifths. And we are going to shade in 2 because that's what it says in the numerator. But we want to make this equal 4/10. So we're going to split this up. We're going to cut each one of these in half. And now this is equaling 4/10 because if we look over here, we've got 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. So this is cut up into 10 pieces. And if you look over here, 1, 2, 3, 4. 4 is in the numerator. So 2/10 and 4/10 are what we call equivalent fractions. In our next one, we have 3/6 is equal to 6/12. Those are equivalent fractions, but we have to prove it by making a tape diagram. So I already started the tape diagram, and it's broken up into 6. 1, 2, 3, 4, 5, 6. And the numerator is telling us that we need to color in 3. So I have 1, 2, and 3. Okay, so now what we have to do, because we want to make it into 6/12. So this section right here represents 3/6, because it's broken up into 6 pieces, and that's the denominator, and we colored in 3 pieces, and that's the numerator. So now we have to actually start cutting this up in half so we could have it equal 6/12. So let's make this here, cut this, this, and this. So let's check out and see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there we go. There's our denominator, 12. And how many do we color in? 6. So let's see if we colored in 6. 1, 2, 3, 4, 5, 6. So each one of these things are going to be 1/12. So each box represents 1/12. And if we compose them and put them back together, they would equal 6/12. So this clearly shows, this tape diagram, that 3/6 is equivalent to 6/12. All right, you guys give it a try now for the next 3 problems. See how you can do. Winning means you're willing to go longer, work harder, and give more than anyone else. Show that 2/3 is equivalent to 8/12 using a tape diagram. And please bring in your tape diagrams tomorrow. Show how 1/2 is equivalent to 3/6 using a tape diagram. And bring in your diagrams tomorrow. And lastly, show how 2/4 and 4/8 are equivalent fractions using a tape diagram. And again, bring the diagrams in tomorrow. You guys are shining stars. Excellent work tonight. Have a wonderful night.